Good morning, YouTube. So this is my Type A Machine Series 1 Pro 3D printer, and as you can see, I've got it torn apart here. Earlier this week I had switched over to printing some PLA filament because I don't think I have printed PLA since I've switched over to BuildTak, and specifically since I've switched to the flex plate here, and also changed to the 0.6 millimeter extruder nozzle. I wanted to dial in the PLA, and I had pretty good luck with that. I think this was a PLA part I printed. About all I had to do to get the PLA dialed in was I used the generic PLA profile that Type A Machines provides, and then I changed the nozzle to 0.6 millimeter and changed the layer thickness to 0.3, and then changed the wall and top bottom layer thickness to 1.2 millimeters. And then the only other thing I did was I turned off the heated print bed, because with BuildTak the PLA sticks really well, and I printed about a 30-minute part. And then I loaded up about a 4-hour print, and I came back after about an hour, and there was a big rat's nest. There was basically that sitting on the build plate, and the extruder was pushed off to the side. And when I went and looked at the Octoprint web interface, the extruder temperature had been oscillating between 220 and low, something below 100 C. And then about the last 30 minutes, it was at room temperature. I thought maybe the extruder had jammed. Or what I noticed was on this print head, this is what's called the X cable. So it's a flat flex ribbon cable that comes into this little circuit board right here. And over here there's a small blue LED that is labeled PWR, so I think that lights up when there's power. In fact, we should be able to see that here. I'll turn the printer on. Yeah, there's the blue LED, and that LED was not on. And then down below there's a small red LED. The red LED comes on when the heater cartridge is getting power. There was no red LED or blue. Well, I tried checking these cables, and they all seemed tight. You know, I thought maybe one of these connectors, either on the carriage here, the Y, I guess this is where there's a little circuit board back on this stepper motor, where there's a cable that goes back and down, and then there's the X cable comes off here. Both those cables seem tight. I've never touched them, so I just checked to make sure they were tight, and they seem to be. So my next thought was to check the main circuit board down in the bottom of the printer, and let me show you what that looks like here. Again, this is the Type A Machine Series 1 Pro, and this is the bottom of the printer. So what you have here, you've got your 24 volt power supply over here, and I guess it probably has a 5 volt output as well. And then this is the main processor here. This is what's called a BeagleBone Black. It's like an open source version of a Raspberry Pi. Very small, like they don't have a lot of connectors. There's just one USB connector, one Ethernet port, and then power over there. So it's a real minimal board. Here's your SD card right there with the firmware on it. I guess the Ethernet is extended out to the back panel. This must be your 5 volt, 5 volt input there. Here's your USB, comes into a small 4-port hub, it looks like. So you've got your Wi-Fi transceiver right here. I think this is the front panel USB port. One of these is probably for the camera, so the webcam is up on the build platform. This cable, I guess, goes over here, and so this is the RUMBA board that has all the stepper motor controller drivers. That's these guys on the top. This printer uses the TMC 2100 stepper drivers, and so those work up to 1/256 microsteppings instead of just having 200 steps per revolution or 1.8 degrees. They can break that 1.8 degrees into 256 microsteps. So that gives you very fine control, and it also makes the stepper motors very quiet when they're operating. And then over here you've got your analog outputs. I think there's 3 high current MOSFET drivers over here. So this is your hot end heater, this is your heated bed plate, and then this third position in the middle would be for a second extruder. And then you've got your pulse width modulated fan outputs, and then there's analog inputs for thermistors. So you could have a thermistor on the main print head, on the second print head, on the build plate. So there's like 3 analog inputs, and I think there's also an analog input for a proximity sensor. So anyway, that's kind of the inside of one of these, and reason I opened it up was I figured there's probably lights on here. I'm going to turn on the print head here, and right there, that's the light saying I'm commanding the print head to turn on, and you can see it heated up, and there goes the fan. The fan's running. Of course, I don't have the print head plugged in to the heatsink, so it's not going to cool off. I'll shut that off here. Anyway, I was getting lights here, and I also measured voltage right there. I was getting 24 volts, so that told me everything down here was working properly. I guess this is where the main ribbon cable, if you can see back there, this is like a little connector board. Here's the main ribbon cable that goes up to the top of the printer, and when I came up here then, I was basically stuck, so I emailed Type A Machines, and the thing they told me to do, let me shut off the printer here. What they told me to do was to pull this cable, the X cable, out, and then swapping ends of the cable, take this end and put it over here, and take this end and put it over here. And so I had tried to do that before, but this connector I found was really tight. In fact, I had really hard time getting it out. But what I found I had to do was push up here with one finger and then get a flat bladed screwdriver in there and lever that bottom piece up. It's really hard here because this fan connector up here is right in the way, so it's hard to get even pressure on those. In fact, this top one doesn't want to come off. So let me try my trick again with the screwdriver. That's why you have to turn the power off when you do that. And there's your flat flex cable. So I pulled this cable off both ends, and this is the end that used to be over there, and that end used to be over here. So I swapped that cable around, plugged it back in, and as you saw, everything was working okay. So what I need to do is put the whole printer back together and get back to Type A Machines, and they said they're going to send me a new X cable. I guess this is probably a fairly common problem on these printers. This cable is rated at 1 million flexures, and 1 million sounds like a really big number. How much is that? Well, I've had this printer. This is August 2017. I got the printer in April 2016. So just round numbers, that's about 500 days. And I've probably averaged about 1 print a day. Some days I do 2 or 3, some days I don't do any, but let's say I've done 500 prints. And a typical part, let me show you one of those. So this is one of the typical parts I print. It's like a round spacer, and then it's got pretty dense infill in there. So these parts are about 1 inch tall, 25 millimeters. Most of these were printed at 0.2 millimeter layer height. So you've got 5 layers for every millimeter. 25 millimeters tall, there's 125 layers in that part. I typically print 4 of those parts. Okay, so instead of printing a really complicated part, Let's just say I was printing something like one of these test cubes, and maybe I was just printing the outline, let alone any infill inside there. You can see there's some infill, but let's just say I was printing the 4 sides. So for every layer, that's 4 carriage motions. Move to the next part, 4, next part 4, next part 4. So you got 125 layers, 4 parts. Gives you 500, and then 4 motions per part is 2,000. So you got 2,000 motions, and then times 500 days, that's 1,000,000. So just printing 4-inch tall cubes per day for 500 days gives you 1,000,000 cycles on that ribbon cable. So yeah, that's probably something to keep an eye on in the future. And with this printer design, everything goes on this one ribbon cable. So if you break one conductor in that ribbon cable, you've got to replace the whole thing. Hard to say if that's good or bad, because I see a lot of these lower end 3D printers or the kits will have all these separate wires. So they'll have the fan wires, the heater wires, all those wires are separate, and then they run all the way back over to the side, into the back, and then down to the bottom and plug into the main board down below. Yeah, so if you've had any problem with these sort of cables breaking in your 3D printer, post up in the comment section below. I just want to see if this is a common problem. I would imagine it is, because you take a wire and start flexing it back and forth millions of times, and who knows what's going to happen. Something to keep an eye on is that cable, and if you don't see your little blue LED, that's the problem right there most likely. And then you can check if the light on the RUMBA board comes on and that light doesn't come on, it's probably that cable. Real simple troubleshooting. Pretty quick fix if the cable itself is not damaged. Just pop it out, plug it back in, and if the light comes on, it's probably good to go. Just thought I'd share that with you. I'll put some other 3D printing videos over here on the side. And as always, thanks for watching.